Okay, so you have here your next example. A 50 kilogram crate shown in the figure rests on a horizontal surface for which the coefficient of kinetic friction mu k is equal to 0.3. If the crate is subjected to a towing force of 400 newtons, determine the velocity of the crate in 3 seconds starting from rest. Okay, so you have here your crate which has a mass of 50 kilograms, wherein it is subjected to a force P which is inclined 30 degrees with respect to the horizontal. The force has a magnitude of 400 Newton. Okay, so basically, for this particular analysis, you need to consider all the forces which would be acting on your crate. So first of all, you would have your force P can be broken down into its components. You would have your horizontal component and you would have your vertical component. You would have your vertical component. So let's have your vertical component as Py and then your horizontal component as Px. Oops. Px. Okay. Of course, Py would be equal to 400 times the cosine or the sine rather of 30, and then Px would be P times the cosine of 30 degrees. Aside from that, you also have the normal force which would be carrying your load or your crate. Let's denote that one as N, normal force N. Now, since your crate is being moved from this point to the next point on this particular direction, there is a frictional resistance between the floor and the crate. Okay, so the interface of, there's a frictional resistance between the interface of the crate and the floor. Okay, wherein the coefficient of kinetic friction of the floor is 0.3 as is stated in the problem. Now, if that's the case and your crate is being moved from this point to being moved on this particular direction, then the resistance would be opposite the direction wherein the crate is being moved. Okay, let's denote that one as F. Okay, wherein F is equal to the normal force acting on that particular, the normal force N acting on this particular point. Okay, or basically that would be the reaction of the floor with respect to the forces which are superimposed on the floor. Okay, multiply that by the coefficient of kinetic friction. Take note, coefficient of kinetic friction is different from coefficient of static friction. When you say coefficient of static friction, it is the frictional resistance between the interface of an object and a surface when the object is not yet moving. Okay? Now, when the object starts to move or when the object is already moving, the frictional resistance responsible for resisting that particular movement would be coefficient of kinetic friction. Okay? So that is from mechanics 1. Okay? So starting with N, taking summation forces, calculating for N, let's just assume first that there would be, or this particular force F or particular force P cannot lift. Okay? Basically, you have your vertical component. So the tendency here is maybe if this one is enough, it can lift your crate. Okay, but if it won't be enough, then the crate stays on this particular upright position. Okay, so if the force or the vertical component is enough to lift that one, then you would have rotation with respect to this particular point. Now that would be another case. Okay, so let's assume first that your your force P is, or let's not assume, how do you check if your P is greater than, or your P is enough to lift that crate? So basically, you take summation forces, or you compare force Py versus 50 kilograms. Okay? So Py is basically equal to what? Py is equal to 400 times the sine of 30. So basically, Py is equal to 200 newtons, while your 50 kilograms, or the weight of the crate, would be equal to 50 times 9.81. Okay, so W is equal to how much? W is equal to, let me calculate that one. 9.81 times, that one is equal to 490.5. Okay, so basically your Py is less than W. So basically your crate will not be lifted. Okay, so let's state it here. Your crate will okay. So since your crate cannot be lifted, then you can now have your N. Okay, so basically N, if the crate will be lifted, then N would not have a value, since there would be no longer a contact surface between the crate and the floor. Okay, so calculating for N, summation forces vertical is equal to 0. Let's take positive upward. That is 0 basically because on the vertical axis, we are in the state of equilibrium. Okay, so positive upward, on the upward direction, you have there N plus Py. And then on the downward direction, you have your weight. That would be equal to 0. So N now would be equal to, transpose to the other side of the equation, W minus Py. So N is equal to W, 490.5 less 200 newtons. Okay, so you would have your normal force N to be equal to, that would be 290.5 newtons. Okay, now taking summation along the horizontal axis, okay, you have Py and F as your forces. Okay, from our equation, summation forces is equal to mass times acceleration. Okay, in this case, if you have here F is, or in sorry, in this case, your forces are Px and F. You have here the mass, and acceleration would be the variable which we will be looking for, or what would be the end acceleration of this particular crate if we apply a 400 Newton load. Now, in the event that F, okay, is equal to or greater than or equal to px, then you can conclude that your crate will not accelerate. Okay, so since you have a greater frictional resistance compared to the applied force to move the crate. Okay, so in this case, let's take positive going to the right. Okay, so to the right, you would have here px, and then to the left, you have minus f. That would be equal to mass times the acceleration of the crate. Of course, you cannot have a negative acceleration since your crate is already at rest. So you look forward to a positive answer when you're being optimistic about the fact that the crate will move. But if you have a negative answer, then that tells us that the crate will not move. Okay, so again, calculating for A, you have here Px, that is 400 times the cosine of 30 minus F. F is equal to the normal force, that is 290.5 times coefficient of friction 0.3 is equal to mass, that is 50 times acceleration. Okay, so you would have here acceleration A now is equal to acceleration is positive 5.18 meters per square seconds. Okay, so that would be the acceleration of your crate. Now, we are looking for the velocity after 3 seconds. So that would be what? From our previous discussion, final velocity is equal to initial velocity VO plus you have a t. Okay? So, initial velocity, that is basically 0 since it starts from rest. So, you would have here final velocity after 3 seconds is 5.18 meters per second square times 3. Okay, so you would have a velocity of 15.5556 meters per seconds.